Hey physics students. So at the beginning of physics class, I like to have a lesson about what is physics. A lot of times students come into class and they don't know what physics is. A lot of times their parents never had to take physics. These days everybody has to take physics, but once upon a time it was not a required class for everybody. So maybe a lot of the adults in the community don't know what physics is because they never had to take it. So I like to, at the beginning of the year, have a little lesson. What is physics? What can we expect to learn in physics class? Stuff like that. So let's go ahead and talk about what is physics and what are we going to learn in physics. Physics is an area of science where we deal with, lots of different things. Okay. One of the parts of physics that we're going to spend a lot of time learning about in class is what's called mechanics. Mechanics, I know you think of the word mechanic and you think of like somebody who fixes cars, but mechanics is the study of motion and the causes of motion. And we're going to spend a lot of time in physics class talking about mechanics. It's really like the bread and butter of physics, right? It's the study of motion, things that cause motion. And, by studying motion, we can predict where things are going to end up after they move. We can predict, how much time is it going to take for something to get someplace, all kinds of different things. We will talk about, in Unit 2, we'll talk about motion in one dimension, which is linear motion, motion in a straight line. We'll talk about, in Unit 3, two-dimensional motion, which is projectile motion. In Unit 4, we'll talk about forces and vectors and the laws of motion. We'll talk about later energy, kinetic energy, potential energy. We'll talk about, work done, falling objects, objects thrown straight up in the air. We'll talk about momentum. We'll talk about what happens in a collision. How can you predict what's going to happen to an object in a collision? We'll talk about circular motion. We'll talk about the orbits of planets, Kepler's laws of motion, Kepler's laws of planetary motion. And towards the end of our talks about mechanics, we'll learn about pendulums. Pendulums go back and forth, right? And that will lead us into the next big area of physics. The next big area of physics that we'll talk about is vibrations and waves. So we'll talk about, waves in the ocean, we'll talk about sound waves, we'll talk about light waves, all that good stuff. And then that'll lead us into another big area of physics, optics. Right? Optics is the study of like lenses and mirrors. So how is light affected when it moves through one thing and into another thing? Or how is it affected when it bounces off of something, right? Optics. The next big area of physics we'll talk about beyond that is electricity and magnetism. Electricity and magnetism is a huge area of physics, right? And then there are some other areas of physics. Thermodynamics is the study of heat and temperature. Fluid dynamics is the study of the motion of fluids, right? Liquids and gases. There's relativity. Relativity is the study of things that move very, very fast, which they behave differently than stuff that doesn't move very, very fast. And then there's quantum mechanics, which is the study of the motions of very, very tiny things. And they don't move the same as things that aren't very, very tiny. So there's a different area of study for that, right? Quantum mechanics. So these are all areas of physics. We will talk about many of them over the course of our class. We won't get to all of them. We probably won't end up talking about relativity or quantum mechanics all that much. Fluid dynamics, we probably won't talk that much about it, but all these other areas of physics over the course of our class, we should learn something about. And there's some interesting stuff for us to take a look at there. So if you took chemistry with me, you are probably used to looking at what's called a model. A model is kind of like a simplified representation of whatever you're trying to look at, learn about, study, whatever, right? Models can be lots of different things. In chemistry, we saw lots of models that were pictures of stuff. We also looked at models that were maybe graphs or charts or something along those lines. And in physics, we're still going to have lots of models, right? Our models in physics are often, we'll see graphs, we'll see charts, we'll see drawings, things along those lines. But what we'll see a lot more of is mathematical models, right? Physics is a very mathematical subject. It's often said, there's an old saying that the universe is written in mathematics. Math is the language of physics. So as we study physics, we're not just interested in, what happens when I throw the ball. We're interested in how much of it happens, right? How far will it go? We're not interested in saying, will it go near or far? We're interested in saying, how many meters will it go? So we're looking for numerical things here. There's going to be some math. There's going to be lots of equations in physics. A high school physics class, there's lots and lots and lots of equations, and we're going to use a lot of algebra. Here and there, we'll also use some trigonometry and some geometry. So these things are all very important for the study of physics. And they are all mathematical models, which we're going to see along the way during our class. Let's talk for a minute about Galileo. Okay, Galileo was an astronomer who lived back around the year 1600-ish, right? Galileo might have been one of the first people you could call a physicist, right? He developed models, he came up with hypotheses, he tested them, did a lot of that kind of stuff. Very interesting character. One of the things that he did, he came up with what's called the law of falling bodies. When you think about falling objects, okay, and it's kind of surprising that before, this time period, nobody really knew the answer to this question. If I were to take a heavy object and a light object, and I were to drop them both at the same time, from the same height, which one would strike the ground first? Seems like a pretty simple thing. Let me get a heavy thing and a light thing, drop them at the same time from the same height, and see what happens, right? But back then, I guess nobody had ever done it before or something, right? What Galileo did is he came up with a model, and he came up with a hypothesis, and then he tested it. He thought about this. He thought about it this way. Let's say I have 2 bricks. I don't have 2 bricks. I have 2 tennis balls, but let's say we had 2 bricks, because this is the picture that I have, okay? He has a heavy brick and a light brick, and he's going to drop them both at the same time. Wants to know what's going to happen. Let's say that the heavy one falls faster. What would happen if I tied the 2 bricks together? If I tied the 2 bricks together and dropped them both at the same time, if the heavy one falls faster, then it's going to fall down, right? And the rope that they're tied together with will pull the lighter one, so it will fall faster than it normally would. But it would also, the lighter one would pull back up on the heavy one to make it fall slower than it normally would, right? So if the heavy one falls faster, they should end up falling some speed in between what they would normally do. But if you tie them together, then the 2 of them tied together are heavier than the heavy one. So then they should fall faster than the heavy one. So this is a weird situation. This is a contradiction. Which one is going to happen, right? Are they going to fall at some speed in between the 2? Or are they going to fall at some speed faster than the heavy one, right? So which is it going to be? It can't be that the heavy one falls faster, because we end up with a contradiction there. What if the lighter one is going to fall faster? Well, you end up with the same contradiction. Okay, the lighter one will pull on the heavier one, and they'll end up at some speed in between. And then the 2 of them together would be slower than the slower one, because they'd be, heavier than the heavy one. So you end up with the same contradiction. So if the heavy one falls faster, you end up with a contradiction in logic. If the lighter one falls faster, you end up with a contradiction in logic. So which is it going to be? And Galileo surmised that they're both going to fall at the same speed, or at least at the same rate. They're going to fall, side by side, right next to each other. So, and then, there's the famous, story. He went up to the Leaning Tower of Pisa and he dropped 2 things, and, they fell side by side right down to the ground. you say, wait a minute, Mr. McQuinn, I have dropped heavy things and light things, and sometimes that heavy thing really does fall faster. Consider, I have a sheet of paper and a notebook. If I drop them, that notebook really does fall faster. Why is that? Well, there's something else going on. It's not just two falling objects. There's something going on called air resistance, right? That sheet of paper is exposed to the air resistance much more than the notebook is, right? And so the air resistance causes it to not fall as fast as it otherwise would. If you were to consider, take the sheet of paper and place it on top of the notebook so it's not exposed to the air underneath it, they fall right alongside each other, right? Really cool thing that happened once upon a time. Scientists talked about this for hundreds of years. They said if you were to drop your sheet of paper and your notebook on the moon, where there is no air, they would just fall right next to each other. And, for centuries, nobody could actually do this because you couldn't actually go to the moon. But then, you could actually go to the moon. And on Apollo, I believe it was 17, might have been 15. It's either 15 or 17. On one of those Apollos, the astronaut went up there. He took with him a hammer and a feather. And on the surface of the moon, on the surface of the Earth, you drop them, clearly that feather is going to hit the ground first. And the feather is just going to kind of float its way down, right? But on the moon, where there's no air, he dropped them. There's a video of this, and they just fall side by side right down to the ground because there's no air resistance. They really do fall at the same rate. Alright, so we have talked a little bit about what physics is. We've talked about some of the different areas of physics, some of the things we're going to learn about over the course of our class. We've talked about models and hypotheses, and we talked about Galileo and the law of falling bodies. So we've done some fun stuff here today. Next time, we'll go ahead and we'll start talking about Unit 1, which is about measurement. We'll learn all kinds of good stuff about measurement and some of the mathematical conventions that we use when we measure things and do physics. Till then, take it easy.